For next, we go to Marco. I can see you have your slides already there. So Marco, you can take the floor.
Do you hear me, Martijn?
Yes, I can hear you.
Excellent.
And I hope the rest also, but I suppose so.
Well, I'll see something in the chat appearing. So thanks a lot, Martijn and Marion, for organizing this great meeting. I've seen a lot of known names in the participant list. So good afternoon, everybody. So this afternoon, I would like to present Predica Diagnostics to you. Predica is a spin-off from the Radboud University, and we are aiming at preventing cervical cancer from happening. Cervical cancer is the third cause of mortality in women. And worldwide, there are about 500,000 cases diagnosed, of which only 50% survive. The cervical cancer is caused by the high-risk HPV virus in almost all cases. And the problem here is that roughly 80%, that you have an 80% chance of being infected with HPV. And luckily, of course, not all infections lead to cervical cancer, and that's only about 0.5%. And the whole problem with cervical cancer is that it is caused by HPV, and it can take, between 5 to 20 years before a really cervical cancer is developing. So there's a real need to prevent, to diagnose HPV and to prevent cervical cancer. What's important for my presentation is that as cervical cancer is caused by HPV, there are about 14 HPV genotypes that can cause cervical cancer. And like I said, after HPV infection, the tissue can develop into a cancer stage, but can also revert back. So there's a real need to have a proper HPV diagnosis and to test whether the cell tissue is prone to cervical cancer development. What's now the problem at the moment is that, this was pre-corona, but normally every year, roughly 600,000 women are tested with national screening for cervical cancer. And because there's a high infection rate of HPV, roughly 60,000 women are diagnosed as HPV positive. And then those tests need to go to cytopathology and then even to colposcopy to see whether there's a cervical cancer development. The problem here is that, luckily there are roughly 58,000 women that don't have to worry at all. So with the current screening procedures, there's lots of overdiagnosis, overtreatment, and lots of worries with women whether they will develop cervical cancer or not. So what this means for us, for the healthcare system in Holland, that there are roughly 40,000 unnecessary follow-ups in cervical cancer, up to 10,000 cases of unnecessary biopsies or surgeries, and of course a lot of women that have worries. Roughly, this is about what this test that we want to develop will prevent those worries, and we can save roughly 25 million in healthcare costs. So to sum it up, the current cervical cancer screening programs are aimed at detecting the presence of the HPV virus. However, the presence is not good enough, because then you get overdiagnosis, anxiety, and high costs. So there's, in general, a need for better cervical screening procedures. And actually, that's what we're doing with Predica. So what we are doing is that we have developed a targeted RNA sequencing technology. And with this technology, we can detect both the presence of the HPV virus, but also its activity. We can measure whether the HPV virus has integrated into the tissue. And we have, we have found roughly 15 genes, of which when they are expressed, it's known that they can have an indication or a risk of cervical cancer development. So what we are doing is developing this test, getting the RNA sequence that is found in these samples, and then develop an algorithm to predict indeed whether, in this case, the woman has a risk of cervical cancer development. How our test looks like is that we will receive the cervical scrapes and then process them into cDNA. With our technology, we can pick up the RNA of choice, so the HPV RNA and the oncogene expressions, the genes that are expressed. We do an RNA sequencing, and we are developing an algorithm in order to make a prediction about possible cervical cancer risk. And there's always a discussion, well, how are we going to bring this to market? And I think that, well, we have a big example here, and that's a company called Testalize.me. What they are doing is that they're offering a online sexually transmittable disease kit. So people can order this kit, take a swab, send this swab back to Testalize.me, and then they perform a test to see which sexually transmitted disease is present in the sample. And via the web, you can then anonymously well, get your result and well, also your treatment advice. So this is one of the marketing routes that we are currently exploring. And of course, we also want to see later on whether we can go to national screening or license our technology for other applications. So cervical cancer screening is one of our first applications, and we will also in the future develop our technology for lung cancer, renal cancer, and brain tumor applications. So what we want to be is to be a leading company in RNA-based cervical cancer diagnostics, developing unique algorithms. We have patents that protect our technology, and we think that we have a high growth potential to other diseases. So, well, I cannot see your faces, but I'm looking for investors that could help us with our development. We're looking to raise roughly between 750 and 1 million euros. We are always looking for a network for software development, oncology, and diagnostics. And of course, as a male, I'm presenting our case of cervical cancer. And well, we are looking for a female business developer that I think could do a much better job at telling our story. My last slide, I'm currently in quarantine because my wife and son are corona positive. So I all wish you well, to be strong, positive, and stay safe at home. And of course, please let me know if you have any questions.
Thank you, Marco. I have one question at this moment, because you say that, of course, you need algorithms to determine risk based on the results. Is it easy to get access to the data to really make reliable algorithms or something like that?
Well, easy is maybe a big word, but we are indeed collaborating with the biobank. We are using scrapes with historical how you call it, diagnosis about the cervical cancer profile, and which oncogenes are expressed. So I think we have the, let's say, the database in order to develop our algorithm.
But you have the database of the diagnostics, but not the database of the outcomes of the people that have been tested there.
Also, we have historical tests, and of course, we also probably will need to develop how you call it, prognostic assays and follow cases. Yeah, that will be part of our development, of course. Yeah.
Thank you. Yes, that means.